Alrighty, folks. It is 10 o'clock at this point, and we're going to go ahead and get started. Now, today, we're going to talk a little bit real quick about prototypes on the prototype chain, and then we're going to get into testing quite a bit. We're starting to see how we can split our programs into smaller pieces, these modules that we've come up with. And a lot of times we do that by encompassing all of that in an object so that our file just exports an object. But there's other ways of doing that too, where you might export like function, just a series of functions or just a regular object. Object-oriented programming isn't the only thing, but there's a lot of valuable things that you'll start to see being useful. One is the idea of encapsulation, where we kind of don't have to think about all that's going on inside of something. Another important piece is that we want things to be kind of standalone, and we want them to be testable. We want software that we can verify that the different parts work independently. We've seen that a little bit as we've sort of written those freehand test.js module yesterday that sort of verified, hey, our weather module worked, our user search module worked, but we don't want to necessarily test a bunch of this stuff by hand. We want to have automated tests so that if something changes, we can kind of encode our assumptions into the program. And if our tests break, we know that we're not using it in the way people assumed we would. And so we might need to change other functionality in the program. We might need to check to see if those tests break, etc., etc., etc. But before we get too deep into that, I want to talk a little bit more about what we saw already. So we saw yesterday, if we looked at the raining cats and dogs, we saw that we could create this constructor called animal. And what it would do is allow us to make objects that were animals. So we would say dogs and cats are both an animal. And we could set different properties on them, etc., etc. Now, one of the things that binds these two together and that makes them a little bit different is they're something we call prototypes. All objects, well, asterisk, have a prototype. And this is how you keep track of what type of thing something is. So if I open up this piece of code, I'm just going to copy this into my browser over here. Have to refresh the page. If I look at dogs, you can see that it's this type animal. And then you'll see that it has a proto of object, which itself keeps track of the fact that it was built with this constructor animal, which itself has this own prototype, which is this object itself. So as it turns out, cats is that way as well. Cats has the same prototype. So if I say, we can see that it was made by the same thing. So if I say dogs.__proto is equal to cats.__proto, it says true. These are in fact the same object. Now, most of the time we're not going to access it too much directly, but there's an important point I want to make here. In JavaScript, when we have things that are made by the same constructor, let's say that we have, let me grab some drawing tools. There we go. So we've got dog and cat. Those are two objects, and they have this thing called a prototype. And it's just an object. And they actually share this in common. They both point directly to it by using the __proto method. They have access to this. And this itself may have a prototype. And then it goes on and on, potentially multiple times, until usually everything just arrives at the object prototype itself. This is how you can call things like dog.toString because it checks on the dog method and it says, do I have a toString method? And it says no. And then it goes, oh, I guess I'll call your prototype and check all the way forward until you realize that there aren't any. So if I say like dogs.toString, it'll say object object. That's the default object response. And so it came in here and it said, oh, I'm going to check on dog. Does this dog's object have a toString method? No. Let me go check its prototype. Does object have a toString method? Yes, and it's the default one, and that's the one we use. However, if I ask for something else, like dogs.makeNoise, you'll notice it says, oh, okay, dogs, the way we've written it currently, has a make noise function, and it's on this object. And in fact, if we go back and we look at the dogs object itself, we can see that it has make noise. Now, this means that dogs and cats share the make noise function, but that functionality is the same. That functionality is the same between dogs and cats. So what we want to do is put it on this shared resource. We want to move it onto the prototype. That way, dogs will say, oh, do I have anything different about me? And it'll be like, do I have it? No, but my prototype does. This way, if I make 12 different animals, I only have one copy of the function as opposed to 12 different copies of the function that happen to be the exact same. So let's look at how we can do that. So if I wanted to, let's use this example since we had it earlier. We're going to pull this piece out and we're going to add something to the animal prototype. We're going to say animal.prototype.makeNoise. And this will actually refer to the object which is calling it. So if we thought about our circles earlier, even if the function is here, if we called it on this object, it's going to use this as the object, or this as the object, whoever called it. Looks kind of like a crazed cartoon character. Can't unsee it. Let's get rid of that. Ooh. So let's look at the difference in the console after we do this. So now if I say dogs, you'll notice that there is no method. There's no make noise method on here. But if I look inside the prototype, you'll see that that's where the make noise function lives. And so now dogs.makeNoise is equal to cats.makeNoise because they're the same one, because they share the same prototype. So whenever I call this, it's going to look at the object and it's going to say, does this object have this property? So I can call dogs.makeNoise and it's going to say, no, I don't directly, but does my prototype? And it checks on the prototype and it says, does my prototype have it? And then it goes, yes. And then it continues from there. So this is called prototypical inheritance. It's different from the way a lot of other languages do inheritance. So some of the other ways like Java or C# or C++ have a different model for inheritance, often called classical inheritance, and it's JavaScript is more of an outlier when it comes to programming languages with how it does inheritance, but it does it in this particular way. So now, if I wanted to, I could extend this and make animal itself a prototype and just add in more information along the way. So I could make a subset of animals called, I don't know, reptiles. And then I could include some reptile specific features that I wanted to, like maybe what's the family of reptile underneath that. And it's been too long since I took biology, so I don't remember where reptile sits in there. I think it's Kingdom phylum class. I think it's phylum, or is it? I don't remember. Nevertheless, that's not the important part here. So let's take a look at this in action. So I've got my array here. This is equal to 2, 4, 6, 8. Who do we appreciate? And then we console.log out that array. We can even go through and console.log out each one of these. Now, my array directly doesn't have this. In fact, let's go ahead and copy this. And I'm going to use var here just so it's easy to redeclare. Most of the time, you would still use const or let. This is just an artifact of teaching it and changing things a bunch. So if I look at my array, I just have this object here. Or it's like an object. But you can see here that we've got this underscore underscore proto property to it. And on there is where we see all of our different methods, like for each, for example, or map, or filter. So by putting this on the array prototype, we're able to access all of these different methods. They share them in common. We can do that with our own objects. Even if I just declare an object like this, even as we declare something directly, it has a prototype. And these are all of its methods. So things like, hey, what was the constructor? In our case, it's just the raw object constructor because we created a object directly, but object itself has a prototype.
So because it's an array, it comes married to all of the prototypes that are associated with an array.
Right. It has the array prototype associated with it, which has all of the methods on it that arrays can use.
Yeah, so it's not based on the variable name, obviously, because that's arbitrary, but just those empty brackets or empty or filled.
Yeah, because we declared it as an array, it then gets access to all those methods. That's how it gets it. That's where it lives. So you'll even notice we can do that on strings and numbers. So let's do that. Let's say var a equals 4, and then I say a dot underscore underscore proto, and look, it's the number prototype that defines all of the different things that we can do with numbers, like change it to a string. So if I say a dot toString, this is 4. That's what happens when I say 4 plus 4. It's calling this thing's toString method and then adding it together. And then it's got all of these other properties. Let's do one of the other ones that we mentioned. If we want to work with a string, we could just say asdf dot underscore underscore proto. And you'll see, hey, here's the string prototype. Here's all of the different things you can do with a string. Right now, so it can calculate all of these and use all of these different functions, and that's how it gets access to them. So underneath the hood, so many things are secretly kind of objects, so they have references to these prototypes. And you can do a lot with them because of that. So in this case, and so all of those are built in. These are just things that get built in, but we can sort of create our own layer of that. So we have movie, and then movie.prototype.loginfo. So all movies are going to share this loginfo method. And then when we call The Shining on this, we can say, hey, does The Shining have its own property, title, loginfo, and does the prototype have that own property? Has own property is a way for us to sort of look at, is this on me as opposed to part of my prototype chain? So let's take a look at that. So in this case, we can see that The Shining has its own property title because that's put in there as part of the constructor. It doesn't have its own property log info because that's part of the prototype. The movie prototype has the property log info. So this is the movie, in a sense, blueprint. The constructor has this dot prototype piece. And any particular instance of it, in our case, The Shining, whenever we call new movie something like that, can reference this by using underscore, underscore, proto, underscore, underscore. Some people will call those double underscore methods or dunder methods. However comfortable you feel with saying dunder in front of other people kind of gates how much you say that. Cool. So that's a little bit about prototypes. We just want to talk about that because you're going to be seeing more of that, especially if you don't use the newer class syntax. You're going to see a lot more of this. We'll look at the class syntax, but the class syntax is just syntactic sugar. It's still translating to this underneath the hood. You're still having that prototype and prototypical inheritance. We might just write it a little bit different. So we're going to start with 07 Tamagotchi. What we want you to do is create a constructor called Digital Pal, and it's got 6 properties and 10 methods. Typically, the way we split this up, as you see here, is that the properties go in the constructor and then the methods go on the prototype. So if I've got pieces of information, that's going to be different per each movie. But how we handle that information, the functions, are not going to change from item to item. In fact, that's why we use this, because it's always going to refer to the movie that we're talking about. So over here, we want you to start out, make 6 properties: hungry, sleepy, bored, their age, their outside house condition. Basically a Tamagotchi, if you ever worked with those. And then, just like real animals, if you feed them, then they go, great, now I'm no longer hungry, but I am sleepy. Then when they're sleepy, they sleep, but then they're bored. And then when they're bored, they can play. But then guess what? They're hungry again, and the cycle continues. So it's got each one of these different methods. Then you'll also add in methods like bark, go outside, go inside for some of these other ones. So you'll just add each one of these on there. You'll create a variable called dog and a variable called cat, and you'll make your new digital pets, etc. We're going to work on this for, let me check the schedule real quick. Just 25 minutes right here at the beginning to kind of give you practice with this concept. So we're going to have you make a Tamagotchi, essentially. If you finish early, go ahead and create a couple new Tamagotchis, play with some of the different methods, and we'll continue after that. So 25 minutes, we're going to go ahead and open up the breakout rooms. If you have any questions along the way, let us know. Good luck.
Hi, Deji. I think you should be able to join your breakout room.
I'm sorry, what did you say?
I said, I think you should be able to join your breakout room. Let me know if you can.
Oh, okay. Awesome. Thank you.
All right, folks, looks like we're mostly back at this point. So what I'm going to do is start just going through this. So we had a couple of different things. We wanted to both add some properties and some methods. And we remember that we want to add the properties directly in the constructor function, and then we add the methods to the prototype. This helps us to use less space while still keeping that flexibility. So const digital pal equals function. Cool. I have a constructor. Fantastic. Now, in this case, we didn't have to have anything passed into it because all digital pals are going to start out the same, which is they're not hungry, they're not sleepy, but they are bored. And then they'll start out at age being 0, and our house quality when we first get these pets is 100, and then that tends to go down. So this dot hungry equals false. This dot sleepy equals false. This dot bored equals true. This dot age equals 0. This dot house quality equals 100. And because this will be different from pet to pet, it goes in the constructor. Next, we're going to go ahead and add some methods, and they're all going to start with digitalpal.prototype. First one is feed. We'll fill those in just a second here. And then we also have sleep. Then we've got play. Destroy furniture. Buy new furniture. Increase age. Let outside, let inside, bark. And meow. Now, some of these things you might consider, hey, this is just for any pet, like feed, sleep, play. Absolutely. But some of these things you might consider to be for multiple different ones, like, hey, this looks pretty cat specific. This looks pretty dog specific. So we'll learn in the future how we can split this functionality up, but I just kind of wanted to highlight it really quick here. I'm going to jump into the solved version just because rather than watching me type it all out. The thing is just to remember this is how we divide everything up. Properties go inside the constructor, methods go on the prototype. Can still access all of them. So what we have here for feed, you'll notice that we use this, and this will always refer to the specific one we're addressing. So the cat, the dog, the bird, the hamster, whatever. So if it's hungry, we're going to console.log that was yummy, switch it from being hungry, set hunger to false, and set sleepy to true. Otherwise, doesn't work. Same thing with sleep. If they're sleepy, then we make that false, but then we make them bored and increase their age. They're a day older at that point. And then we've got play. If it's bored, then we'll make it not bored, but now we'll make it hungry, and the cycle continues. For destroying furniture, we again work with those different properties where we lower the house quality. For buy new furniture, we increase the house quality. Whenever we increase the age just goes up. And then letting outside and letting inside. Cool. So we can make new ones. We can even tie them to being part of a command line. And then we can even make it arbitrarily work by saying no Tamagotchi cat meow by working off of the name of the different properties, which is pretty cool. Now at this point, we might do something at the bottom after we've tested all of the pieces and we made sure it worked. We would say something like module.exports equals digital pal. And now the rest of the program, whatever else we want to write, can use this as well. But as the digital PAL evolves, as it changes more and more over time, we want to be able to make sure that it keeps working. We want to make sure that it doesn't just stay stuck. And to do that, we would do some things with automated testing. And we might discover after the fact that wow, this can be kind of hard to test. It's not easy for us to do so. That might be something you run into as you're programming new things. So we're going to introduce a topic today, and we're going to spend most of today talking about it, called test-driven development, or TDD. Before we talk about it in a lot of detail, we want you to kind of go out there, explore it, research it the same you would when you hear any new techniques. There's always going to be new programming trends and paradigms and ideas out there, and it's good to be able to sort of practice the skill of acquainting yourself what it is. You hear a coworker talk about it, you read a blog post in your news feed to keep up with different trends, and you're like, what is this? We're going to pretend that's kind of what we started with here. So we're going to just spend a little bit of time researching what is test-driven development. So I'm going to go ahead and post kind of a prompt to just research what is test-driven development. It'll have a couple of questions. Let me post that in class activities real quick. And then in your groups, we're going to spend just a little bit of time answering those questions. There we go. So I posted the 3 questions, and you could replace test-driven development in here with anything, and those are good things to Google whenever you hear about it. What is test-driven development? What is it for? What are its advantages? What are its disadvantages? We're going to open up the breakout rooms for y'all to discuss this together, and we'll hear the answers when we come back. Good luck. All right, folks, so let's start answering these questions. There we go. So, based off of your research, what is test-driven development? Or what kind of differentiates it from other stuff? All right, if I don't get any volunteers, I get to pick some folks. That'll be fun.
You basically write and run a set of tests before you write the code.
It's hard to run the test before you write the code, but yes, absolutely. So we write tests
cases
before you write the code. And so all of our tests start out failing because the code isn't there, and then we make them work. What were you saying, Matt?
It's just saying, like, you create test cases so you can, like, if you're like thinking through your problem, you say, okay, these are the potential outcomes that we can potentially see. So you write those test cases and then code to create those true test cases.
Yeah, it's a lot about forcing you to think about stuff before you actually write the code. It's a lot of what is going on with test-driven development. And let's see, what are its advantages? I guess we already listed some of it, which is forced to think about it ahead of time. What else?
Keeps bugs to a minimum.
You can help find bugs early, keeping them at a minimum.
You're less afraid to change the code?
Less afraid because you have tests. That's just true of tests in general. But it's definitely an advantage of test-driven development because the idea is you always have tests. Some other stuff I'm going to add in myself is that it encourages modular, loosely coupled code. So your things are more separated. They're not, you only tie them together where it needs to be tied together. Your modules are a lot more coherent that way. What about some of the disadvantages? What might be some downsides?
It can't find the bugs within the test.
Well, technically you can write tests for your tests. Big brain. But yes, that's also there. And then I heard someone else start, and then unfortunately we were talking at the same time. So whoever that was, you had something you wanted to add.
Be time consuming?
It can be time consuming, that's for sure. If we think about our MVP and the idea of getting something out to the user as quickly as possible, you sort of run that against that. What else?
Does it focus more on like small chunks and not the complete picture?
You might lose the holistic picture. Depends on how you do it, but that's definitely a risk that can happen. And it can be also difficult if you don't understand the problem particularly well at the outset. TDD kind of depends on you knowing what you're doing at the beginning. And as y'all have experienced with a number of your homeworks, a lot of times you kind of discover how to do it along the way. So TDD depends a lot on accurately knowing what you're moving forward with. So that's kind of a list. I'm going to post this list into Slack, that we came up with together, and then we'll talk about it a little bit more. So that's the list we came up with. So we're going to show you some code here. If you open up 08 student TD dissect, you'll notice that it depends on, or you've got a package.json, and there's this thing called dev dependencies Jest. Dev dependencies, as we remember, aren't required to run the project, but they are for the final version of the code, but they're kind of scaffolding around the project to make working on the project easier. And this is one called Jest. So I'm going to go ahead and follow me as I do this. I'm going to open up this spot in the terminal. I should really close all the other ones I'm not using at some point. Let's actually do that real quick.
Which space are you opening?
So 08 student TDD dissect. So we're going to open this up in the terminal. I'm going to run npm install. Which will take a little bit. While we're in here, we've got an index.js. We can see that index.js uses this arithmetic module, which lets us do a bunch of operations in sequence. And then if we look at arithmetic.js, we can see it follows that pattern of, hey, here's our constructor, here's all of the different methods, that'll be a part of it, and then we're exporting it. The new piece is this test. and it's got some stuff going on. So hopefully it doesn't take too long to install Jest. I would highly encourage you starting that off now while you're looking through the file. But you can see there's a number of different things that are happening. Once all of this is finished, let's also go ahead and just stop for now. Jest can be a pretty big library. This is another one of the reasons we put node modules in our git ignore, because some of these things are really, really big, and that would take up a lot of space in our repo, especially if we ever updated a dependency. So once that's done, oh, looks like it just finished. I'm going to run npm test. Oh, it just got stuck. That'll be fun. It tried to do something and then ran into some issues. Anyway, let's take a look at the README rather than just staring at that today. There we go. So the README will have you going through each one of these different pieces and starting to look at, hey, what does all of this do? Once you've had the time to do that, go ahead and say npm run test, and you'll see the following happen. You're not going to be editing any code. You're just going to be doing npm install and then npm run test. This will run the program called Jest, and it'll sort of tell us, hey, are all of these different pieces working by running the test that we saw. What we're going to do is give you 10 minutes to just kind of run through the code, pay particular attention to arithmetic.js and arithmetic.test.js. Index.js is all right, but it just kind of shows it in use. And you can see here that we've got little check marks next to any one of these different pieces. What we want you to do is just take a look at it, break apart this section of files as much as you can, and then we'll talk about it in about 10 minutes. So we'll see you in about 10 minutes. Good luck. Looks like most folks are piling back in at this point. So we're going to go ahead and start reviewing some of what we talked about. So this uses the Jest testing framework. Jest is a framework that was made by the developers over at facebook.com, and then they open sourced it so that the rest of us can use it as well. It pairs particularly well with React, which is one of the reasons for its popularity, but it's used independent of that, and it's a great JavaScript testing framework. You'll also see references to the Mocha framework and the Chai assertion library out there. Mocha and Chai are two other ones that, if you're looking for other testing frameworks, get used quite a bit. But we're going to be working with Jest in this course. So here's our actual program, index.js, and what it does is it just adds together a bunch of different pieces. So we start out with the number 4, we add 8, we add 15, we subtract 16, we subtract 23, we add 42, we add 108, and then we ask for the value at the end. Very common to see objects that let us chain together a bunch of different operations one after another. A little bit overkill perhaps for what we're doing here, but not a bad start. So let's look at the arithmetic module. The arithmetic module, we start out, we initialize the value to a number, plus we'll increase that number to the new value, and we actually return a new arithmetic operator. This is not too uncommon in other things. Basically, the idea is you're trying to keep these objects immutable, meaning that you're never going to modify a value. You're going to always create a new value based off of the previous one. At no point are we ever changing an existing value. We're always giving back something new. But that's an implementation detail. That's just how they decided to write it. What we want to look at real quick is the test. You can see that the test is inside of a folder, and it's called arithmetic.test.js. It's done this way so that Jest knows to automatically look here, and it knows that this is a file that we want to run in the Jest framework model. Now, when we do that, we get a few new global variables. Just like when we run stuff in the environment of the browser, we can use window and document. When we run stuff in the context of Jest, we get a few new functions and variables because of that. So up at the top, we grab the thing we're testing. Hey, we're testing the arithmetic module. Let's grab a reference to it. We sort of group them together by using this describe terminology right here. When we ran npm test right up here at the beginning, you'll notice that we have it all in this test arithmetic.test.js, and then you'll notice that this structure right here mimics what we're seeing here. So we're going to test arithmetic, we're going to test how it's initialized, we're going to test the plus action, we're going to test the minus action, we're going to test the value action. So we start out with the whole object, the whole class, the whole constructor itself, and then we work our way through each one of the methods, including the constructor and then the three other ones, so that we make sure that we're testing all of it. So in this case, we then say it should do something. It is the actual test function itself, but we like to write it so that it reads just like a sentence. It should return an object containing a number property when called with the new keyword. So let's check that out. We say const object equals new arithmetic, and then we use this new expect function. Expect the number in object to equal true. So this is a special way of writing, and you can do this in regular JavaScript. It's saying, go ahead and give me the value of number in object if it exists. So that's one part. We should set the number when created. So const number equals 108. Const object equals new arithmetic with that number. And then we expect object.number to equal number. Now, some of this might seem a little redundant or really simple, but it's also there to just make sure that it's behaving the way we expect. If the rest of our program and the rest of our team expects this to have a property called number, and we change that, we want the tests to break so that we know, hey, other people might depend on this. It's not just some internal variable that we're using. Other people are probably going to use it. If we don't provide one, we want to make sure the number defaults to 0. That's a decision we made. We could have also thrown an exception and be like, hey, you have to initialize it with something if we want it to always be explicit. In this case, we decided to say, hey, it should be 0, and we have a test that backs that up. So that's a couple of different cases right there. Next, with plus, we see it should return a new arithmetic object when we call plus. You can see this instance of modifier. Instance of is kind of like type of, but for constructors. So our object is a type of, or is an instance of arithmetic. It belongs to that constructor type. Since if we just use type of, it would just say object. We want to be a little bit more specific than that, so we're using this operator called instance of. So if the object is an instance of arithmetic, we're expecting that to be equal to true. If this wasn't the case, let's in fact go ahead and change this and run it again. We will get an error. And it will say, hey, this particular test that you were running earlier, we expected it to be this, and it was actually this. Let's take a look. So it's pointing out to us, hey, this test failed. We should return, it should return a new, should return a new arithmetic object. We notice that's got a little X next to it. So that test didn't pass. So we know exactly which one didn't pass. The rest of them did fine. So we expected false, but we received true from that. So sometimes the problem is in our arithmetic code. It might be wrong, but the problem could also be potentially in our test. And at the very least, we notice that there's an incongruence and we need to fix it in one of the two places. Either our tests might be out of date or just have a bug in them themselves, or the code that we wrote isn't correct. That's one of the reasons it's really important to write out the test with a good name, because then you kind of know, hey, which is it? How should it behave as you're investigating that piece of behavior? Cool. The rest of these kind of do the same thing. So that kind of talks about each one of those. So the three things to remember about this, or the three sort of actions, is we have describe and it. Describe lets you sort of group tests or other groups together. And it is for writing actual tests. So you'll have describe, and then you'll have it most of the time. Inside of it, you want to use expect. Expect will say, this is what should happen, and then we compare the results of doing something to what should happen. So this is often expect. So you expect result to be 4 or something like that would be a common example, though there's other ones as well. And this is where we make something called assertions. We're saying it should be this, it should be this, and if it's not, it's broken. So that's some of the important stuff that we saw there earlier. So, and that once all of the tests pass, we can actually hook this up into automated systems that will say, hey, all the tests pass, great. Just like we did for Project 1, where we had people review the code and then approve the merge requests, we can actually set up automated testing like this to make sure that all of the tests pass before we allow it to be merged into the master branch. This allows us to prevent it from just accidentally adding in something that either we or the other reviewer didn't catch. We have this suite of tests so that they work. There's different kinds of tests. This test is just testing this particular small component, so we call it a unit test because it's testing the unit of arithmetic. There's other kinds as well, but unit tests are probably the most popular. Any questions about what we see here? All right, if there's no tests, then no questions, then we're going to give you the opportunity to work on some of this. So we've got this unsolved folder. Inside of that, you'll find index.js. Index.js has a written program. And then you've got algo.js. This is your use case, what you want it to look like. It'll give you a little bit more insight on what you're supposed to do. And these are different algorithms that we want you to write. Reversing a string, checking if that string is a palindrome, capitalizing different parts of the string. There's different details inside of the README. The tests are also not written. So what we want you to do, in this case, start out by writing the tests. You don't have how the functionality works. You just have how it should look. So we want you to start out in this section by just writing the tests at the beginning. So if you look inside of the README, you'll see in this activity, you will write tests outlining the expected functionality for application code that hasn't been implemented yet. So don't worry about implementing the code yet. Don't worry about writing the actual thing. We're doing test-driven development, which means we write the tests first. We have the interface that we know we want. We know that these are going to be the 3 functions that are going to be part of this module, but we don't know how they work. We just know what are we going to get from them, what are we going to get back. The internals, we don't know. So you're going to be writing tests for these and use the previous model. If you have questions, let us know. We're going to spend 15 minutes working on this, and then we're going to review it right before lunch, and then we'll break for lunch, and we'll look at actually making the test pass by implementing the functionality. So 15 minutes, we're going to open up your breakout rooms. If you have questions along the way, please let us know, but you're writing the tests first. Good luck. Alrighty, folks, we're going to go ahead and write a couple of different tests here. We're going to just come up with a few to begin with. First of all, let's start out with number 5 for reverse. A great way would be it almost always starts out with it should reverse a given string. And then we include a function which will test that for us. So let's start out with a string. Let's say str equals, I don't know, someone give me something that's not a palindrome, for example.
Banana.
Banana. So banana backwards. So the reverse of that, well, reversed equals ANAN. No, yeah, NAB, ananab. So very close, but not quite. And so now we have manually tested this to see if it works. So we're going to get the result equals new algo dot reverse our string, and we expect what we get back to equal what we wrote earlier. Now this function is not actually implemented, so we can't run it yet, but this is what our expectation would be. This is kind of the minimum you would do when testing something. You would make sure that the golden path works, that if people are using it as expected, it performs like it should. Some tests that we haven't included here yet are, what if people give us a number? What do we do with that number? Do we convert it to a string? Do we throw an error? That's part of what we can do when we're writing tests, is make decisions about that. What should happen, especially in these edge cases or these non-standard cases. So let's go on to is palindrome. Now this is an is question. So whenever we want to test something like this, we often think about a positive and a negative case. Let's return something. If it's a palindrome, it should say, hey, it's a palindrome. If it's not a palindrome, we should say, hey, guess what? That's not a palindrome. So let's take a palindrome. So we will say it should return true if a string is a palindrome, or if you reverse it, it looks the exact same. So we're going to say, all right, we've got this palindrome. Let's say taco cat, one of my favorites. And this is going to be true, but that's pretty easy to inline, so we're just going to write it out there. Const result equals new algo dot is palindrome string. We expect that result to be, or to equal, true. That's a palindrome. It should work. Let's also, and this is a positive case. We also want to do that for negative cases. Let's go ahead and just say burrito.
Taco dog.
Taco dog, that works too. Taco dog is not the same forwards and backwards. So it returns false if a string is not a palindrome. So we expect that to be equal to false, etc. Lastly, we have our capitalized one. Just in the interest of time, I'm going to have us look at the solved version of this. It should take a string and return a new string with the first letter of each word capitalized. So we have this first one, capitalize every first word of the string. The capitalized version of that, we make a new algorithm object we call the capitalize method, and then we expect it to return equal. You could have also just organized this as an object with a collection of functions associated with it. You don't necessarily need to make a new algo for it if you're coming up with everything yourself. But in this scenario, that's how we set it up. Cool. So when we come back from lunch, we're going to try and write our functionality so that these tests pass. If you have any questions about it, feel free to let us know. We'd love to help you out with it. If you post them in Slack, I can answer them right at the beginning when we come back from lunch. Other than that, it's lunchtime. We'll see you at 12:45. Have a good one.
What's happening, Corey?
Not much, Stephen. How are you?
Oh, another fun, great day.
Yeah.
Did you get, how far did you get with the homework from last night?
So after I deleted the repository, I set up all the questions again, and then I listed out like fs dot write to file or write file. I don't know why it said write to file. Did you use that?
No, I deleted it and I did the write file async method.
Oh, write file async. I didn't do
Yeah.
that. So
let me pull mine up real quick and I'll tell you exactly, because we just went over it and I'm all like, that's part of what we learned in this course. So I'm going to go ahead and utilize it for the homework because it's so much easier to use.
right. So I set up those functions, but like as far like I don't even think Inquirer that I installed that correctly.
Mhm.
And I overheard Elliot saying earlier that like when he did it, it like showed all these changes, like 5,000 plus. And I was like, someone else ran into the same problem.
Yep. So
Yeah.
I did a constant write file async is equal to util.promisify, and then in parentheses, the fs.write file.
Oh, so you wrapped it all in that?
Yep.
Okay. Did you do each one like that, or did you put all of those functions within that?
No. So the only thing that's in that is I have the constant, which is the write file async, which is a function, equal to the util.promisify fs.write file. So that's going, hey, I'm writing a file. That's the fs.write file. I'm putting it in a promisify that's saying, hey, I don't have anything yet, but I'm going to have something. And I'm making that all equal to the write file async, which means that all of that is going to happen at the same time that I'm doing whatever other function I'm doing. And so that write file async, I had that as a return. So it was return write file async. And then in that parentheses is like the what you would have when you did a normal write file. So I had the, readme.md in parentheses or in quotation marks, comma, answers. And that answers is, my data that I got, that I recorded. And I had that as a return from the initialize function that I ran that asks you all the questions.
Sounds pretty good.
Oh, hey, everyone's back.
Yeah, it's 12:45.
All right.
Bless me. All right. Welcome back, everyone. Excuse me. Stepped outside, and maybe that was a bad idea for the allergies alone, which I tend to get pretty bad. So if I'm sneezing, I'm going to try and hit the mute button. We'll see. All right. So we're going to continue on. When we had started before, when we were working on this before lunch, we were looking at it and we were saying, all right, let's write the tests first, because that's what test-driven development is about. Let's write these tests first. A lot of test-driven development means a lot of things to a lot of people, but a general consensus is part of it is writing your tests first, which we did. So if you open up O10 unsolved and you look inside the test folder, you'll actually see that we have a copy of each one of the tests that we wrote already when we did that before lunch. If you're confident in your tests, you can continue working in O9 if you want. Either way, you'll want to run npm install. And what you'll be doing is actually writing the reverse is palindrome and capitalized functions. And then you'll be able to run the tests and see if it works. So if I'm in, let's see, 10 unsolved, You'll need to run npm install to get a copy of Jest installed in that particular location. Once you've done that, you'll run npm test. Npm test will tell you if each one of those things are passing. If they're not, then what you'll need to do is go ahead and actually fill in the test, and if they still aren't passing, you've got an error somewhere in your logic, and you can work on that. So we're going to open up the breakout rooms. At this point, we'll go ahead and give you 15 minutes to work on this, and we'll review it after that. So 15 minutes. We'll see you then. Good luck.
Hi.
Alrighty, folks. Looks like we're mostly back. Still waiting for a few people to come back in, but I just started this off by saying npm run test, and I can see that algo.test.js, this test suite, this test group, has failed. And in fact, all of the tests inside of it have failed. And that's what we start out with test-driven development. Everything starts out red with the X's next to it, and we want it to go green, where it's given us the little check mark that says this one works. Let's start with reverse by itself. So we're going to go into, let's see, that would be this one, yes. And we want to make sure that this works when we reverse it. There we go. So we'll start out with reverse. Fortunately, there is an array method called reverse, and we can convert a string into an array if we split it like so. Then we can say dot reverse, which will flip all of the elements, and then we can join them back together. So we run our test again. That says go ahead and run algo.test.js, and we can see that one of our tests actually passed. And that's the one that we just wrote. So we're pretty sure that reverse works at this point. You could have used plenty of other methods as well. You could have used a for loop where you assembled a string and you went backwards, or you added it to the other side. That would work fine as well. There's more than one way to do this. We don't care necessarily about how you do it. We just care that it passed the test. If we look at the test, it doesn't really care how you do it. It just cares, did it work? So that's what we want when we're writing tests. We don't want to test that the person chose the right way to do it, as there often is a multitude of ways to do this. We want to test if their results are correct when we're doing this kind of testing. Now, if something is a palindrome, we can actually leverage some of what we had before. So we can say return this dot reverse. So we're actually going to check if we reverse this string, is it the same as the string we got? If it is, it's a palindrome. If it's not, then it's not. Let's go ahead and run this. We should get 2 more tests that pass at this case, both the positive and the negative version of the reverse test. So it looks like I still have an issue here. Let's see. Should return true. If a string is a palindrome, that's not going, expecting result to equal true. So let's check that. That should be working correctly. Interesting. Let's double check that. So let's double check our tests. So let's save our ASDF equals this dot reverse string, and then let's console.log out the 2. This way we can tell if the problem is our algorithm or the problem is our test, and maybe we wrote something incorrectly. Okay, race car, that looks correct. Neon, those are not opposite. Oh, okay, it passed. My guess is that I didn't save when I ran it the first time. So that works. Next we should take a string and return a new string with the first letter of each word capitalized. Now we can use our split trick again to make an array of the different things that we want to capitalize. So we're going to do this in segments. We're going to say return string dot split. That gives us an array. At the other end, we'll join those back together But in the meantime, we want to do some other stuff. There's a few more things that we want to do. Whenever we take in something and return or take in an array and then transform it into an array based off of the same input, we can use map. So we're going to take each word and we're going to do something to it. We're going to take in each word, grab the first letter, capitalize it, and then return the rest of the word as it was. So we're going to return word.substring 0.1.2 uppercase. What this does is it just capitalizes the first letter. And then we'll add the rest of the word. Again, the important thing isn't that you solved it the same way that I did. You could have used for loops or other tricks as well in order to do this. You could have done a for loop, and after you split up each one of the words and then just took the first letter and said, all right, let me get the capital version of that, and then used for loops to go through the whole thing. Just knowing some of the extra methods is nice, but it's not necessary. If you did it a different way when your test passed, your test passed. It's fine. So let's go ahead and run this again, make sure that we've saved. And now all of our tests should pass. Oh, looks like we're still missing one. Let's see, what did it not like? We need to put in word.substring1. Must have accidentally deleted it in there. What did it not like?
Substring.
Oh, I put substring, which is not a thing. Thank you, Matt. There we go. And so all of our tests passed. So this test suite has passed, which is great. So if you did this a different way, completely fine. For example, we could have done this with a for loop. For var I equals string dot str, or let's say I equals 0, I is less than string dot length I plus plus. Var result equals blank, and you could have said result equals string I plus result, return result, and that would reverse it as well. So there's nothing wrong with having different implementations. In fact, we can save this, run it again, and we'll see that the tests still pass. And that's nice because it means we don't need to care too much about how you're implementing it. We can just say, as long as it passes the test, it should work. Let's see. Oh, I put that in the is palindrome section. Oops. Let's fix that. There we go. And again, the tests help us prevent careless accidents like that, where they'll be like, this is broken, you made a mistake, and it won't let us integrate it into the main branch. But there we go. Different implementation, still passes the tests. It's fine. Cool. Now, one of the questions we might get after this is, well, how do I know how to write tests? How can I organize them so that they work properly? Well, one of the good things to do is to test when you're working with objects. Let's look at the test that we have. We have one for each one of the methods because it doesn't initialize any values. If the constructor took arguments, we might do that. We might still add that in here. But I want to look at this next stage right here. So we're going to write tests. Let me move us into here. We've got index.js. We've got this to-do list and this to-do component. So we've got to-do list and then these to-dos as well. If we look at our tests, we've got a test for each one. So whenever you have a module like this, it's good to write a test per one of them. Let's look at todo.js first. todo.js is pretty simple. It doesn't have a lot of methods to it. It's largely just this data constructor. And the to-do constructor is largely about making sure that everything is correct. It's about validating that, hey, if you try and make one of these that's out of not a string or out of an empty string, it's going to throw an error. And so that's most of what we test. We want to make sure that it works when it's valid, and we want to make sure that it works when we have an invalid input. So if we look at todo.test, we've got two tests, both under the heading of initialization, because there's no other methods. So here's our two tests: the positive test, which is it working correctly, and the exception test. The exception test is when it's giving an error. These are the two most common that you'll see when you're writing tests. So let's look at the structure here, and we'll see that we've got these comments: arrange, act, assert. These three A's sort of describe the three steps that we go through. The first thing is that we do all of our setup at the beginning. We set the input that we're going to use. We then act. This is the actual thing that we're testing to see if it works. We want to make sure that when we make a new object with some text, that it works correctly. And the assert is just making sure that everything went as it should. So object.text is equal to the original text that we put in there. So that's arrange, act, and assert. Arrange, set everything up beforehand. Act is do the thing that you're testing, and assert is make sure that it is acting like you expect. The three A's. With the exception test, we can see that it follows that same pattern, except we're expecting an error. We kind of combine the act and assert here. You'll notice that when we test for exceptions, we can't run it immediately. And this is because it would throw an error, and the testing program would error out. So instead, what we do is we pass a callback, and that callback specifies what the series of actions to do that will create the error. So for example, here, we don't pass any text to the to-do. It's going to throw an error. So we encompass that in a function. This is the error that we expect to get back. And so we expect CB, when it's called, to throw this error so that the error messages match. So that's how you can test exception cases. You set up a function that will do what you want, but will throw an error, and then you pass that off to the expect method. Let's look at to-do list as well. So on to-do list.js, we've got a few more methods we got to worry about. We've got initializing it, but then we've got add to do, get next to do, and complete next to do. So we've got three different methods. So inside of the test, we're going to test the initialization, the first method, the second method, and the third method. Again, following this pattern of let's make sure that it works the way that we want. So in initialization, we just have one, the positive test case. We're not passing it any input, so it makes sense that we just have one test. It should create an object with a to-dos property set to an empty array when called with the new keyword. We could test to see if it's throwing an error or something like that, or if it's not called with the new keyword, but we're not doing that at this point. So we arrange to-do list equals new to-do list, and then we assert. Sometimes act will get thrown in with either arrange or assert, but it's helpful to think of them in these three steps. So sometimes the act will jump onto one or the other, but it's good to think of them as these three steps. So when we make a new to-do list, it should just work. It should just work. So this is a combination of kind of arrange and act because we're setting everything up to test. The next one, we have add to do. This one has a positive test and the exception test again. The positive test, we arrange the new to-do list. We're not worried about testing whether the to-do list works because we've got another test that up here that works. That's not the part that we're testing. We're testing if when we add a to-do, that works correctly. So we set this up, we add in the to-do list, we act, and then we test everything that should happen as a result. The length should have increased by 1. the thing that got added should be a to-do. And the text of that to-do should be equal to what we added. If any of those things don't work, then we haven't successfully added a to-do. If any of those three conditions don't pass, then it doesn't work. Next, we're going to see what if we throw bad input at it? What if we throw a number, a Boolean, or some kind of input that shouldn't work? So again, we arrange, we set up what the error is, and then this is kind of our act portion, but it's in a callback because this is an exception test. The exception tests are always going to have callbacks like this. If we don't, then they'll error out the testing suite themselves, which we don't want. So we put that in here and we assert that this is the error thrown if we try and add to do with no input text. Get next to do has a positive test and a negative test. Now a negative test is different. It's not an exception. It's something that you might honestly do that it's a potentially valid thing to do, but nothing will result. A common example of that was the is palindrome. A positive example of that would be, hey, it is a palindrome, and a negative example would be, it's not a palindrome. So positive and negative tests are different from exception tests. Exception tests will result in errors in the program. Positive and negative tests are both valid operations. They just return different kinds of things. So for a positive test, we want to return the 0th element in the to-dos array without removing it when we call get next to do. So we arrange it by coming up with a couple of different to-dos. We add the two different to-dos, and then we get next to do. It should be the first one. So we expect that to be an instance of to do. We expect that text to equal exercise and not wash car or something like that. And we expect the to-do length to be equal to 2. This would be a positive test, again, following that arrange, act, assert pattern. Arrange is where you set up variables, act is where you call methods, assert is where you call expect. A negative test. What if we don't have anything in our to-dos list? Well, that's still a valid call. That's not an error. You might still ask for it. And so we have a negative test to handle that. What happens when we don't have to-dos and we ask for the next to-do? So in our case, we're asserting that we expect to get back undefined. So the type of next to-do, what we get back, should be undefined. So it shouldn't error out if we ask for the next to-do and there aren't any. It should just be like, hey, there aren't any. The same way that if you asked for something in an array and you asked for an index that was out of bounds, it returns undefined. Very similar for complete next to do. In this case, we just have the positive test. You should always have at least a positive test when you're testing a method. You might also throw in a negative and an exception test, but you should always make sure it at least works positively when everything is working correctly. So it should return and remove the next to do in the list. We make each one of those, we add the two to-dos, we complete the next to do, and then we go through each one of these. Now you might notice there's some repetition. There's some repetition between the get next to do that we do for here, for example, and the one we do down here. There's a lot of repetition. Tests are one of the few places where we don't mind repeating ourselves quite a bit because we want to sort of keep these in isolation from each other. We're trying to test this exact thing within the act. It's okay if the setup is similar around each one of the edges. It makes the test a lot easier to read rather than having to bounce around and look at the different functions that we're using. It's very simple to see what we're testing. We're setting this up, we're checking if it works, and we're asserting that it did work, or we're performing the actions and making sure it worked. Any questions on how we're organizing tests or setting it up or anything like that? Cool. So We've got the 3 A's. What are the 3 A's? Question time, quiz time.
Arrange, act, assert.
Assert.
Arrange, act, assert. Can I get a volunteer to tell me about what arrange does?
Where you set it up.
Yeah. This is our setup phase. So any setup you need to do happens in the arrange phase. So oftentimes that means creating things, setting variables that you're going to use later, etc., etc. All right. Corey, could you go ahead and pick someone to go next for us?
I've got Jessamine.
All right, Jessamine. Act. What happens when we act?
I am still grasping this, so I'm going to go ahead and pass it.
All right, to who?
Okay, I get to pick somebody.
Mhm.
I'm going to pass it to Daniel Vega.
All right, Daniel.
Acts when you'd actually do the method that you're testing out.
Yeah. Do the thing we are testing. That's what we're testing. That should be describing what happens when we have the it should up at the top. It's basically that. Awesome. Pick someone to go ahead and tell us what assert means for this last one.
I'm going to pick Steven.
Steven.
Assert is making sure that your expected results are equal to the results that you're getting, that they have occurred.
Paraphrasing you a little bit there, I think. Cool. Now, you don't always necessarily need to comment these out into separate stages like we did here, and you see sometimes that we combine them, but you should be thinking of these 3 stages as you write them. And it will help call out, hey, what exactly is this? And it might help you to literally comment out the 3 different sections so that you remember the steps to do. Now, we talked about 3 different kinds of tests. Does anyone remember them? Stephen, go ahead and pick someone for us.
Let's go with Matt Moline.
Matt Moline. Awesome. So, Matt, what are the 3 different kinds of tests that we looked at?
Honestly, I'm not actually sure.
For sure. You can pass it off to someone else if you'd like.
Right. I'm going to pass it off to Jordan. He's on my screen.
All right, Jordan.
Nice. Positive, negative, and exception.
Yes. So positive, negative, and exception. So positive and negative are sort of normal, the thing works. In fact, you should always have a positive case. Sometimes there isn't really much of a negative or exception case. It's just, did it do the thing? Like addition, hey, did you add numbers together? But even then, you can often think of an exception case. If I'm doing addition and I pass in letters or true or some other weird thing that's not a number, what do? Do I throw an exception? Do I just let it naturally error out? So positive and exception cases are the most common. Negative cases, you'll often see on there, especially if you're doing something like a check, like is palindrome. Any method that starts with is and returns a Boolean, you'll almost always have it return true or false. So you'll have a positive and negative case there, but there's not really a negative case for addition, right? It's like, okay, yeah, it didn't add it, that doesn't necessarily make sense, but it helps us to sort of think about the normal order. Another one might be like, hey, get the next item in the queue. What if the queue is empty? What if there's no one else in line? Well, let's handle that with a negative case. It's perfectly valid to ask for something that we don't know if it's there or not. We won't error out, we'll just return undefined if that's the case. So that would be another example of the negative types. So you should always have the positive case for each method that you're testing. You should probably have exception on there, and you might have negative as well. So always positive, often exception, and sometimes negative. Exceptions, you'll always wrap the behavior in a callback, because if you tried to execute it directly, it would throw an error which would error out the test. So you're going to always wrap the exception act part in a callback like we saw earlier. Cool. So that's a little bit about having to work with tests. We're going to give you the opportunity to work with some of this structure as well inside of 12 student structured tests. So let's look at what we have here. So in our index.js, this is our main program. We're not testing this program as a whole, we're just testing the smaller pieces. When we test those individual pieces and not how they connect together, we call that unit tests. You can test, there's other types of tests like integration tests, end-to-end tests. There's even things like performance tests, which are more concerned with how fast you do something. But we're largely going to be talking about unit tests and making sure that individual pieces that we work with work. So to that end, we can see inside of tests, we've got one test for each one of these modules, one for child and one for daycare. What we want you to do is, if you look inside of child.js, you'll notice some things about it. It has a constructor, for example, kind of like our to-do that we had earlier, but it doesn't have any methods. So you'll need to write some tests for that in here. For daycare, daycare has an initializer, but it also has a number of methods. We should add tests for those as well, at least positive tests, tests that it works, often exception tests, and potentially negative tests as well. A great example of a negative test would be, what if we try and pick up a child and that child doesn't exist in the daycare? What if we try and pick up a child who doesn't exist in the daycare? Another great example of adding a child, a negative test would be, hey, what if we're at capacity and we can't take any more children? Does it work properly? Does it say we shouldn't add another child, etc.? An exception test here would be something like, hey, what if we try and add like a dog to the daycare? And we're like, sorry, we're not a doggy daycare, we're a child daycare, no matter how you feel about your pet. And then we storm off in a huff, unfortunately. And we come back and the dog now has a mustache and a shirt on. It's great. With that out of the way, what I want you to do is write some structured tests around this. Now, this test-driven development where we already have it and then we're writing tests after the fact? It's not. I'm seeing some heads shaking because we don't lead with the tests. But it's still good to have tests even if you don't write them up front. More tests is generally considered to be a good thing. In fact, a lot of times when you're first starting out, you might start out by looking at the tests or adding your own tests in order to start getting familiar with the code base and learning how it should work. The tests are actually, in a way, a form of documentation about how these things should act, which is pretty cool. So we're going to go ahead and open up the breakout rooms. We're going to take the next 15 minutes to work on this, and then we'll review it. And after that, we're going to talk about how we can sort of use stand-ins for other classes that might not be done or that we need to just have stand-ins for by introducing something called mocks. But we'll do that after this exercise. So 15 minutes, we're opening up the breakout rooms. Good luck. Alrighty, folks. Let's go ahead and go through this together. So let's look at these tests, and we can see the pattern that kind of emerges from them. So we'll start out with the child. The child is a relatively simple data object. We see that there's some exceptions to be thrown, so we should write a test for each one of those exceptions, and then we want to write a positive test to make sure that it works. So let's go over to our tests. So all of these are described inside of the initialization. So we have one test group for our constructor, and then it's going to have a couple of different tests in it. Now, in this case, we've got a bunch of different ways that it could potentially work. So it should create an object with a name and age if provided valid arguments. Without looking at the contents, is this a positive, negative, or exception case?
Positive.
Positive.
Positive. Should work correctly. It should throw an error if provided no arguments, positive, negative, or exception.
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 Exception. We see the word error in that. In fact, that's the case for all of the rest of these. Oftentimes, you're going to have more exception cases than necessarily the golden proper way to do it, because there are oftentimes more things to screw something up than to do it the correct way. And so we want to be responsible in handling those edges. Cool, so let's dive into here. We see that this is kind of two phases built into one. Which of the two phases is this?
The arrange and the act.
Arrange and act. And that's often the case when we work with constructors, where the creating the object is the thing that we're testing. And then we've got the assert afterwards. So we expect the child's name to equal Sarah, and we expect the child's age to equal 3. Next, we've got, again, kind of the same thing, which happens with exceptions, where we need to set this up. We arrange the callback, and then we expect and assert it, because expect will run the callback for us. What would happen if I just tried to do const c equals new child? Why can't I just do that?
That would actually throw an error right there without like breaking out the test.
For sure, that would cause an error to happen in the test without something to happen. Sometimes you'll see it in other frameworks where people will say try catch the error themselves and then expect the error to be something like that. You'll see things in that format as well. That's just not how Jest does it. Jest is expecting a callback most of the time, or at least that's the convention. You could probably still make it work if you wanted to. So that's the convention, where you create a function to do the erroneous behavior for you. We'll see that in here. So we're improperly calling the constructor. This time we're missing an age. So this is, what if we provide nothing? What if we provide a child without an age? What if we provide a child and it's named 3? I guess this would probably fail with Elon Musk's new kid or something like that. I'm not sure. But as long as it was a string, it'd be fine. And then if the age isn't a number, like they write it as 2, or if the age is negative. So there's a lot of potential cases that we're covering here that we want to make sure that those work. This is what you might call defensive style programming, where you want to make sure that, hey, whatever gets handed to you, you can handle. You'll either error in a positive way, where you're saying, I don't know how to handle this. This is specifically what you did wrong. But as soon as it encounters the error, it changes it around. Cool, let's look at daycare here. Now, you'll notice we have a test suite per method, one for the initialization and then one for each of the methods. Let's go through and look at each one. So it should create an object with a children array, capacity number, and an age limit number. Is this going to be a positive, negative, or exception test?
Positive.
Positive test. Add child. We've got a couple in here. So it should add a child to the children array. Positive, negative, exception.
Positive.
Positive. It should not add a child over the age limit. Positive, negative, exception.
Negative.
Negative. It's still valid behavior, but we want to sort of test when things aren't going where what they're doing doesn't succeed, but it's not an error, or it doesn't return true. Sometimes the words for the differentiating between those can be a little tricky, but negative cases, very importantly, not an error. That would be an exception case if we encountered errors. Should not add a child if already at capacity. Is
Negative.
which? Negative. Should throw an error if not provided a child object as an argument.
Exception.
It's an exception. Excellent. So just looking at each one of these, that's how it works. In this case, we get to see the arrange, act, assert pattern laid out a little bit better. Constructors are usually a little bit weird, but the other methods tend to be more direct. Again, we try that here. Arrange, act, assert. And even though it looks like there's repetition in tests, we're usually okay with that. What we want is to make it very clear when you read the test what's happening. And having a function that you have to go look at somewhere else that's doing this over and over again can be difficult for that. So in tests, we are less dry than in the rest of our program. Same thing is going on here. Again, we've got arrange, act, assert. And you might call other methods or set other stuff up beforehand. This is what we're actually testing because we're testing the add child method. And when you write tests, you want to test one thing per test. And we're just testing this specific thing. We don't want to group it together. Like, hey, let's write and make sure we don't want to write a test that says can't add invalid child. We want to break it up into a couple of different cases that could be. They're over the age limit. We're full. Hey, that's not a child. Things like that. So we don't want to group them together necessarily. We want to sort of split out the different cases. And this is, hey, what if you try and pass in just like a name or something? Then it's going to say, hey, this should be an instance of child. And then that works. Same thing with pickup child as well. Questions? All righty. Cool. So there's one more thing or one more topic I really want to introduce today, and that's the idea of mocks. Now, up until this point in our testing, we've just kind of been testing to see if some result happened the way that we wanted. Like, hey, give me a value or something like that. But what we haven't really tested is things like side effects. Things like, hey, I need to write something to the file system, or I need to make an AJAX request. We haven't been able to test those exactly because when we run the tests, we don't necessarily want to send those requests. If I'm saying like, hey, if I want to write a test that says, please add this track to my Spotify playlist, I would prefer it if it didn't actually do that. But the code shouldn't have to know that that's the case, that I've swapped something else out into it. It should just act like nothing's different. So what we're going to introduce is this idea of a mock. It's something that looks the same to the program, like what we were using before, but it's actually substituted out for something else. We're sort of switching things up behind the scenes. You might think of it like a facade or an old West town where you have, hey, here's what looks like the front of a saloon, but right behind it's just the front face of it. And then behind it is just, I don't know, the rest of the production lot or something like that. So it's meant to just sort of act like it's there, but it doesn't actually use any of the changes. So let's take a look at an example. So we've got index.js right here, and we've got this function, or sorry, this object right here called logger, which we can use to write logs out to the terminal or out to the console. So we can log it out in different colors, kind of like we could if we were using chalk, etc. But when we test this, we don't necessarily want to write stuff out to the console because that would interfere with our test suite and it would sort of intrude on all of our different statuses. We don't want to see that in the console. We want the program to just call it, but not actually output it to the console. If we look at logger.js, we can see that it actually uses console.log to do that. So here's the different colors, and then what this is doing is it's dynamically making a method for each one of those based off of the colors. It's pretty cool stuff. But the main thing we want to take away from this is this has side effects with console.log. It's calling this extra piece out here. So in our test, we want to say, actually, don't use console.log. Don't use console.log. So we're going to come over to logger.test.js. We have all of our different tests. We have a few colors up here just for convenience sake. It's a mirror of the colors we see here in Logger, so they should match up to each other. And we're going to test, it should print in black. It should print in red, green, yellow, blue, etc. We want to test that each one of the colors work, but we don't want to actually console.log out anything. All of these are just positive tests. We're not looking at negative tests. We're not looking at exception tests. So as part of the arrange step, we're going to use this special function, jest.spyon, the console object, look for whenever someone calls the log function. Whenever someone calls the log function, run this instead. And what we're saying will happen instead is nothing. This is just an arrow function that doesn't do anything. So what we're kind of doing is injecting into the program, hey, whenever you call console.log, just don't actually do anything. And so we say log.black message. This is our arrange step. But if we can't look at the console manually, how do we know if it worked correctly? How do we know if it called console.log? Well, we can actually ask, hey, mock, when someone called console.log, what did they call you with? And they called us with the color black and the message. So if we look here at console.log, we can see that we have colors key and args. So this changes this to be black and then changes the color back over. So this can tell us, hey, was the thing that we are mocking, was it called the correct way? So this is our stand-in. It's like we are doing a rehearsal or something and the other actor isn't there. So we have one actor talk to one of the production assistants like, hey, let me read my lines to you as if I were that other character. The other person's not in character, but it just gives them a chance to practice and they can verify, oh, you did your lines correctly, or oh, you didn't do your lines correctly. That's the whole idea behind a mock. We don't actually have those changes be called. We're just putting something in the middle. And once we're done, we call mock.mock_restore, which says, okay, I'm not spying on you anymore. It goes back to the regular console.log. But between here and here, console.log doesn't do anything. Console.log isn't going to do anything because there's a mock in the way. And that's the generic term we use for these things. We have a mock in the way, our facade in the way. Questions?
Mock is part of Jest, right?
Yes. And since Jest is the thing running this folder, we get, just like we get describe, and it, just because we're running in the Jest environment, which is slightly different than the regular node environment, we also get this Jest thing that gives us the ability to spy on the console object and call log the way that we want. And so we say, this actually isn't it. That doesn't work. And that's just for the duration of this test. And all of these other colors pretty much work out the exact same. Very, very similar tests. A lot of repetition, but remember what I said, in tests, we don't mind the repetition. So we could see, oh, if we tried to use a color that didn't work, it would do something else. We expect all of these different things to work. It's an example. Cool. So what we want you all to do is to try using some mocks yourself. Now, if we look in our program, it's the daycare program again, and you'll notice that we have console.logs scattered throughout the functionality. While we're testing, we don't want these console.logs to fire. We just want to say, hey, did it work or did it not work? So coming into our tests, if we look at child.test, daycare.test, etc., all the tests are already written. What we want you to do is introduce a mock object so that we don't see that. So familiarize yourself with it. Look at those JS files. They look pretty much identical. And add code to spy on the console.log method to ensure that it's called when expected with the correct arguments. Let's look at this. So here, let's look at child.js, for example. Or sorry, daycare.js. We expect to see, if we try and pick up a child that isn't in the daycare, we expect the console to get child not found. And we can do that with a mock. Or if they are found, we expect to see picked up whoever from daycare. So we can add on that piece. We can test these side effects without them actually appearing in the console as well. Same thing for unable to add child, at capacity, etc. So using the example inside of introduce mocks, we want you to go ahead and spy on console.log, make sure that it doesn't output anything while we're testing, and make sure that the correct thing is called in the different scenarios. So find the tests associated with the different scenarios and insert the correct mocks at those points. So we'll be working on this for the next 15 minutes. If you have questions, let us know. We'd love to help you out. Good luck. Alrighty, folks, we're still waiting for everyone to pile back in, but looks like everyone's about to be here. So we're going to go through the solved version of this. Now we came through and if we look in our unsolved version, a lot of our tests are already there, but we're going to add some mock tests to it as well. So if we look here at child.test.js, we're not really using it much here because our child doesn't output to the console. If we look in our child object, we don't really see console.log here anywhere. So no need to mock it, no need to put anything in there. We already have comprehensive test coverage. Daycare, however, does. We see console.logs all over the place with these side effects, as we think of them. Things that are happening and affecting outside of just the normal flow. Data is, in a sense, leaking into the rest of the program. So we have daycare, and let's look the constructor. If we look in here, the constructor doesn't really have any console.logs, not needed. We see this for the first time in each one of these methods with add child. So let's look at our add child tests and see what's different. So as part of our add child tests, it should add a child to the children's array. It should not go over the age limit. But here inside should not go over the age limit since there's a console.log in response to that. One of the things that we do here is we start out by making a mock that spies on console, specifically the log method. And we say, and it won't output anything. It won't output anything. And then we expect the mock to have, and let's put these two side by side so we can really see it. If we try and add one over the age limit, we see unable to add child. They are over the age limit, and we're checking that this is called unable to add child. They are over the age limit. You'll also see that I guess we don't have it up here, but we could add it in there without too much trouble. Someone rang the doorbell for Amazon. Can you all hear my dog? Okay, we'll see if we can keep that quiet. She usually calms down before too long. Let's check. It should not add a child if already at capacity. That's good to hear. Should not add a child if already at capacity. So we're checking this case where we spy on it. We have a mock implementation, and then we expect to be called with at capacity, unable to add children. So we're adding this into our tests already to make sure that it's acting appropriately. When we add a child, if there is no issues, we just add the child and it's quiet, which is why we didn't have the mock for the positive case. It's in these negative cases when we would output something to the user saying, hey, we can't add this child, that we use it. Same thing happens for pickup child. If we see a place where we would console.log out the pickup child, like if we don't have that child in the array, we would put that there. However, we also see it in this case, in the positive case. So in our positive case over here, we also do the mock implementation to make sure that it's taken care of. So in your test cases, you only need to handle the stuff that would happen. Now you'll notice that we don't check picked up blank from daycare because we don't go down that path in the negative case. So you only need to assert that these things happen or substitute them in there if there's an actual console.log that will show up. If it's not there, if we don't go down a path that uses that, we don't need to change anything. Now this is good because we've got console.log in here, and that's great for just replacing a single method. What I want to talk about right here at the end, we'll talk about it a little bit more during office hours, is just what would we do if we had like a whole module that we wanted to use? Let's say that we're working with someone else's module and either that module's not done or it has a bunch of side effects. We want to just sort of substitute something, whether maybe it's a pre-done module out there like Axios and we don't want to actually make API calls to something out there. Let's take a look at how we can do that. So in number 15, index.js, this is a movie search, uses the OMDB API, so we can look for Spider-Man. And movie search.js we can see uses Axios, and this movie search has a way for us to build a URL and then call search in order to grab it. And it uses the Axios module to do that. Obviously, in our testing, we don't want to use up our precious API calls actually getting information about Spider-Man. We want to just get that information. So let's look at how we handle that. So inside of test, we've got Axios, movie search. we build the URL. We don't need to mock anything here because this is just building the URL. It's not calling Axios or anything like that when we build the URL. So we're fine leaving that alone. Let me move this over here. And we'll get rid of these other pieces so we can see all of it at once. Get rid of this real quick so that we can put them all side by side. Awesome. Cool. So when we test the search method, you'll see that we have axios.get mock return value. So we are going to return something in its place. So we say, hey, here's when you say axios.get anything, we're going to just return back this data. It's an empty data object. You could also populate it with actual data about Rocky if you felt like it, but this is going to prevent us from when we call movie.search from actually making an Axios call out to this URL. It's going to instead, whenever we call axios.get in this case, do this instead. It's going to return this whole value. We don't have to return a function, we're just returning this. And you could do that with other stuff. When you're expecting promises, because it's asynchronous, you can actually say expect that something resolves to this value. Because it's asynchronous, we can't just say expect it to be this. You can say expect it to resolve to that value. And then we can even call axios.get and say it should be less called with this movie URL that we built. So it lets us kind of step in there with Axios and change out some of those different pieces that we might need to use. So lets us mock that up quite a bit. Cool. We'll talk about testing, just kind of a review more during office hours, but it's the end of class for today. When we start on class tomorrow, or not tomorrow, Monday, when we start on class Monday, we're going to be talking a little bit about classes, which is an ES6 way of handling a lot of this constructor prototype type stuff. It's the newer syntax, and we're going to be using that a lot more going forward rather than the traditional, here's a constructor, here's the methods we set on its prototype. It makes that a little bit easier. We'll give you a chance to work with that. And then we'll also start talking about web servers finally next week, which will be fun. How can we finally take all this stuff we learned about Node and start applying it to answering requests from browsers? That'll be pretty fun. So we're going to take a few minutes, just grab water, get all set up for office hours if you're signed up for one-on-ones. And if you have other questions that you can answer, want answered, you can post them in Slack as well, and I'll look through Slack and see if there's any questions there, and we'll answer those right at the beginning. And then we'll just talk more about testing primarily. This will be office hours primarily about kind of that stuff that we covered today. We're not going to dive into a ton of detail in the future on this, but it's an important topic, and it's one it's good to get more and more familiar with throughout your career. Cool. So we'll see you all in a few minutes. We're going to be setting up in just a second here. We'll see you in like 3 minutes. All my pets got faked out when I went for water. They're like, "You're done? Yay, it's time to." And then I walk back in here and they're all sad. It's great. It's the worst. All right, so I'm going to go ahead, and it doesn't look like we posted, I don't see any questions posted in office hours, so let's open it up to the verbals. Any questions y'all had so far about testing or any of the other stuff that we covered today?
Not even sure like what questions to ask.
For sure. And also, if there's other questions that might have fermented from working with something previously, like about the homework that you turned in last night, or anything else, those are fair game as well.
Sorry, I'm looking over some of the stuff we went through. I don't know. I think the biggest thing is just there's a whole lot of new syntax coming into play.
Totally. But they're mostly just functions. They're new global functions for the most part. When you run stuff in Jest, is everything else is kind of the same syntax for the most part. But there's other frameworks out there like Mocha and Chai. We just happen to like Jest. I like Jest because it combines a lot of stuff. With Mocha and Chai, you often have a lot of libraries that you're putting together to make it do what you want. With Jest, it gives you a little bit more out of the box.
Let's see.
Hey, Eric, I wanted to look at the homework that was due next Tuesday this weekend, like while I'm reviewing like everything we've gone over.
For sure.
Do you mind kind of going over that really fast?
Yeah, sure. We can talk about that.
Thank you.
So it's actually going to be pretty similar because you just finished making a markdown file generator, right? And so what you're going to be doing is instead of generating a markdown file, you're going to be generating an HTML file. And so what you're going to use is the Inquirer package. And we can talk about the structure of these looping Inquirer programs a little bit today during office hours. But you're going to say, hey, I'm putting together a team. Please enter a whole bunch of information about the team. So they would have entered in, hey, this is Jared, they're a manager. This is their email. This is their office number since they're a manager. Here's Alec, they're an engineer since they're an engineer. Here's their email and their GitHub. Since here's a John who's an intern, here's their email, and then their school because they're an intern. So it's going to be very similar to what you did before, except you're a little bit more modular about what you're putting in there. So depending on the different type of person, you're going to be putting different HTML onto the page. But it just is there to generate it just like the markdown homework. So if you wanted to do a looping, let's talk about how you could do that. Hey, we want to keep going through something until it stops. So if we were to draw a diagram of those steps, let's talk about that really quick. So we have our starting point, and our starting point is often a series of menu options for what do you want to do. So in our case, let's just write down what those would be. Let's say that we want to, let's say we're making an app that is, hey, enter a list of movies. Enter a list of movies, and each time we say, hey, are you done? So the questions will say, please enter a favorite movie. And then you do that. Then we ask, would you like to add more? and they either say yes or no. And then we ask, would you like to know more about these movies? And then they say yes or no. And then we would say, would you like to start over? Yes, no, or we could even add an option to each one of them for exit or something like that. But let's just say that we add that at the end here. Yes, no, exit. Series of questions, and we're potentially looping over that. Let's draw out what that structure looks like. And this is just with one option. You can change it for multiple ones. So we start out here at our first node, which is, would you please enter a favorite movie? We just say, hey, you have to do that at the beginning. From there, once we've entered our favorite movie, we've kind of got a couple of different choices. We have, would you like to add more? Yes, the result of that. And would you like to add more? No. And so we can think of these as different functions that we're going between. No. So if it's yes, if they click yes, well, technically we're going to loop back around here. So this, believe it or not, is really kind of looping back to enter a favorite movie. So this is kind of a looping structure where you can say, hey, I would like to keep adding movies again and again and again and again. Once we click no, we then ask the question, let's go ahead and label this part. Then we get to ask, would you like to know more about these movies? That has the option of yes and no. And then once we've done that, we would say, would you like to start over? Which again has an option of yes and no, and it'll loop back. So drawing out a diagram that helps you sort of know about the different stages is helpful. And so let's actually write out a function or each one of the steps. So enter a favorite movie. User enters movie. Would you like to add more? Yes. Then we would loop back to here. No, we'll move down to this next. Would you like to know more about these movies? If it's yes, then we're going to make an AJAX call. So we're going to go to the OMDB API and ask for a movie at that point. And once that's finished, then we can move on to the next step and say, would you like to start over? So if we click yes here, we'll stop here. And then once that's done, we'll come here. If we click no, we're just going to go straight there. Would you like to start over? Yes. Brings us back here. And then no or exit. We're done with the program. So it's good to think about these as kind of functions. So this would be to prompt the user. The user enters a movie, and then we prompt them again, would you like to add more? So let's come up with some names for these. So function ask movie, and I'll clear the drawings really quick. Function ask more. Function ask details. Function ask start over. So all of these have to do with asking questions. And then we could put some of the other things in here, like when we have external network, things like function get movie details. And so how do we structure all of these together? How do we tie those? Well, with our arrows, tell us how we structure those. So with function ask movies, and this is us pseudo coding the steps in, if yes, or we would say inquirer.prompt, we're going to omit that, then answers, if answers, or we'll say, and we'll include some data out here, const movie list equals empty array, or we could even say let. We'll say let this time. And we would say movie list dot push, let's see, answers dot title or something like that. From here, we move on to the ask more section. In ask more, we have another inquirer.prompt. And there's if answer dot more is true, then we're going to go ahead and call ask movie again. Otherwise, we're going to call ask details. And we know that because if we drew arrows between these different events, when the user enters a movie, we can see inside of ask movie, we then need to ask them, do they want to do more each time? If we would like to add more, then we come here again, which will then trail this again. The no will bring us down here, which is the ask details function. If they say yes, that's going to take us to the OMDP API. If they say no, that'll take us straight down here. So let's clear that out. It doesn't do particularly well with scrolling. So based off of this, inside of ask details, where can I go? What are the functions that ask details will take us to?
We'll get the information about the movie, right? Or
yeah. So
right,
one
right
possible one is get movie details. And what's the other possible one? Like, what if we say no to would you like to know more?
Is it start over?
Then we say ask start over. So we know that we'll call those functions from within there. With ask start over, what are our sort of two possibilities? Because that's asking, would you like to start over? So if we want to start over, where do we go next? So if yes, we would like to start, then we'll call ask movie. And if they say no, well, in a sense, we don't go anywhere, right? So we just exit. We're done at that point. If they click on get movie details, once we get movie details and display it to the user, what do we do after that?
I mean, you could save it somewhere for them or write it for them.
Yeah, we could ask other things, but we just ask if they want to keep going in this case. But you can see you would have your diagram of circles, and then you could just draw from one to another what's happening. So let's draw out this sort of in post after we reasoned about it. So we've got ask movie right at the beginning here. Ask movie potentially leads to, or always leads to ask more. Ask more potentially leads to one of two other options. So we'll call this, we'll just write the text on there. So this is ask movie. This one is ask more. This one is, and technically, let me actually, let's get rid of those. It's much easier if I have a whiteboard in front of me, I promise. So ask movie always leads to ask more. Ask more might lead back to ask movie, or it might go on to our next one, which is
Detail.
ask details. Yes. Ask details is then going to say, all right, I could go to get movie details or ask start over. So we'll start going down, I guess, at this point. So here's kind of our two different options. Details or ask start over. So these are the two directions that it could go. Get movie details, as it turns out, we'll go right back here. And then ask start over either exits the program or brings us back to this diagram. And so this gives us functions and which functions call each other. And we could even sort of split these out into different modules. Now, there might be some pieces that have to help orchestrate all of these together, depending on what you're doing. But this kind of gives you a way to even split up some of the different pieces and see who depends on who. Now, we always have this bigger structure that's kind of going on here. So they kind of need to be aware of each other at some level. So like ask movie and ask start over, technically we have this weird circular dependency. So I'm just going to put them all in one big file like this. But get movie details, that's pretty easy to pull out for asking the Ajax about it. And then we could have each one of the questions from Inquirer be their own promise. So let's structure that. Let's sort of keep this diagram off to the side and let's make a quick project to put this in. New folder in here called example, and I need this because Inquirer needs us to have packages. npm init-y, npm install Inquirer. I think that's correct. It's one of those things, I've seen it so many times that I'm starting to question how it works. So let's make a new file and we'll call this one questions.js. I'm also going to install Axios after that, so I'll make another new file called api.js. And in questions, I'm just going to make some small functions here. So I'm going to say module.exports equals a big object. This is a little bit different than how we saw it with a constructor. But I'm going to say ask movie. And this is going to return Inquirer. Let's go ahead and make sure that's up here at the top. .prompt, and then my series, my question. In this case, it's going to be something pretty simple like, let's see, that would be type input message, what movie do you want to know more about? Unfortunately, it's overlapping a little bit with our diagram. So let's see if we can move this diagram out of the way. There we go. So I suspect we'll be running into that quite a bit when it looks like some of the text didn't make the journey. And so now I have just a section with each one of my questions, and I've labeled each one of them. So I could say like, ask more. Ask details. Ask start over, etc. And this is really nice because it's really easy to mock up this object. I just return a promise with the answer I want if I want to try and simulate the user's input. So what movie do you want to know more about? They type it in. If we're asking for ask more, we would say, would you like to add more movies? We would say that this is a type confirm. Another type confirm. Would you like to know more? And then another confirm. Would you like to start over? So now I can just ask these questions and I can think about them at this level. I don't need to worry about the individual text. It's kind of easy to see them. So I'm going to make a new file called index.js. And now I can describe this structure. So I'm going to import, or not import, const questions equals require dot slash questions. Actually, we'll just start with questions. So to kick us off, I want to use, and I might actually use destructuring at this point. Let's actually do that. Ask movie, ask more, ask details, ask start over. So I'm going to ask a movie. Then with the, let's see, questions. Oh, I forgot to give these things names. That's important. Don't want to forget that. We'll just call these confirm for each one of these, because these are all yes or no questions. Then we'll take the title. And then we decide what to do. So I'm actually going to call this function begin. And I need this just so that I can reference it to do the circular behavior again. Because at the very end of this big long chain, I'm going to call begin. So I kick it off with begin down here. So I ask a movie. From there, I'm going to return ask more. Dot then, if, and that'll be confirm is what I'm interested in there. If confirm we need to call ask more. Let's see. So this is another loop, so we'll need that. So we'll say function enter movies. So we'll start out by confirm, enter movies. You can see that you need to kind of break out functions whenever you get this kind of loop behavior so that you can reference them. So if we want to keep going, then we just call enter movies again. Otherwise, we'll continue. So we'll say ask details and then continue from there, or we can make that a whole separate function. Ask details then. If confirm, else ask start over. Might be better not to try and segment this. No, that's fine actually. Start over, begin. Else. There we go. So this is kind of complicatedly this structure to the left here without any of the intermediates. So we don't have get movie details because we haven't written it yet. But it would be on there. Let's see. All right, so get movie details. And then we would call the rest of it. Can get a little bit tricky structuring it. And that's mostly because I tried to like separate it out into promises. If you just model them as functions that could potentially call each other, it actually gets a lot simpler. So let's do that. Yeah, we'll just keep those in there. So function, ask movie, ask more, ask details, get movie details, whoop, ask start over. And we'll import, or sorry, const questions equals require questions. And this will be a little bit confusing because we've named the questions the same thing. In fact, let's just go ahead and pull this out. So we won't use this. Dot then answer if answer dot title, actually no, we'll just say let titles equal this, titles dot push, answer dot title, ask more. No need to make it too complicated. Dot then answer if answer dot confirm, then we would just call ask movie again. Otherwise, we would call ask details. Dot. Then we take the answer. If answer dot confirm, then we would do get movie details, which we'll fill out in just a second. Otherwise, we would call ask start over. We'll come back to get movie details. Ask start over. Would be inquirer.prompt. Then answer if answer.confirm. Then we would start it off at the beginning, but we would do a few other things first. We would reset the titles array. So titles equals empty object or empty array. That's why we have it equal to a let instead of const because of the reset we have here. And then we would say ask movie at the beginning. And if not, console.log, thanks. So for get movie details, we're just going to immediately call ask start over. We'll say console.log. We want to get the details for the following movies. And then we could say console.log, whatever we labeled it, titles, I guess. .join /n. So let's try it out. Node index.js. Oh, we forgot to kick it off at the beginning. We would call ask movie to kick it all off. Inquirer is not defined. Really? I guess I forgot to add that up at the top here. You can tell it's a Friday afternoon. There we go. Let's try this again. So, what movie do you want to know more about? Here we are, the ask movie function. I would like to know more about Shrek, because why not? Would you like to add more movies? Sure. What movie do you want to know more about? Audience choice.
Stick with the tried and true Frozen.
Frozen, why not? And you can see that every time we do this, we have this looping behavior. So it keeps asking us again and again as long as our answer is yes. So let's go ahead and let's say Mad Max as our last one. Would you like to add more movies? No. Okay, cool. We have now moved on to the ask details. Would you like to know more? Yes, we would. We want to get details for these movies. Shrek, Frozen, Mad Max. Would you like to start over? Sure. Let's say Star Wars. Let's say Remember the Titans. Add no more movies. Would you like to know more? Yes, that's the ones we want to get more info about. Would you like to start over? Yes. Let's say that we want to know about Shrek. We don't want to add more movies. We don't want to know more. We don't want to start over. We're done. So that's how we can track through all of those statements. We build kind of a function for each one of these little nodes, and then we model how to get from one to the other. Now for get movie details, we're going to separate that out a little bit, but go ahead.
Is the confirm always just going to prompt a yes or a no?
Yeah. Yeah, it'll always confirm yes or no, which it will model as true or false for you. So you can just use confirm for that. Or you could do choices if you wanted to have more than one choice. But let's now look at this. So I'm going to make npm install Axios, make sure we have that. And then I'm going to say const Axios equals this. And we might model get movie details. We might say like, okay, for this stage, we actually need to do some stuff. What's that going to be? In our case, it's going to be, hey, this is a module, and it's going to take in a list of movies and return us the information about them. So I'm going to say const get movie details, and this is just going to be a function. And this function is going to take in a list of titles, and then it's going to return those. So I might even say, and then I can come down here and say module.exports equals get movie details. And putting it in its own module is nice because then I can make unit tests against it, different things like that as well. So to do this, well, that's actually going to be kind of complicated, right? Because I have a bunch of different network calls that I potentially need to make. So I'm going to make myself a helper function that is get movie info by title. This is not a function I'm going to export because this is all about just helping me. The rest of the module doesn't need to be able to get things individually. It just needs to be able to get a whole bunch of titles. I'm going to do this here. So I'm going to say axios.get that URL. So that's https://www.omdbapi.com /t equals title and API key equals trilogy. And I'm going to say then, let's see, return this. Then I'm going to take the response and I'm going to return the response.data. That means I just don't have to do that later. So next I'm going to take each one of these titles and I'm going to say return promise.all titles.map title get movie info by title. So this is going to return one promise that resolves when all of its individual promises resolve. So it's kind of a catch-all that does a lot of the heavy lifting for us. So we can come back into our index.js and let's we can load all of this into here. We can say const API equals require ./API.js. And down here, I'm going to say API.getMovieDetails, the titles list. Once we've done that, we'll get the movies data array. And we'll decide what we want to do with it. Let's just go with the title and the year. So we'll say console.log. Let's see. Log title or movies data array dot map movie return movie dot title dash movie dot year. And then we're going to join these together with some new lines. And then once we've console.logged all of that out, we'll ask to start over. Cool. Let's try it out. So what movie do I want to know more about? Let's say Shrek. Sure, let's also do Treasure Island. Sure, let's do Peter Pan. And we're good. Would you like to know more? Yes, please. There's Shrek, Treasure Island, Peter Pan. We console.logged out each one of those individually. That was somewhere in here. We told it to do that. And then there's each one of them individually. That should, I'm wondering where we put the console.log. Oh, that's the titles.join in. Yeah.
Hey, Eric, real quick, can you go back to
Gotcha.
the API code?
Sure.
I guess like on line 3, they get movie info by title, having to return twice. That like those, can you just explain that real quick?
For sure. So this is a return for the get movie info by title function. So this returns this whole thing. This whole thing is a promise. And it's kind of a multi-stage promise. It returns a promise that has all of the data from the API, and then I'm adding this extra piece in there, which is going to say, actually, before you hand it back through this, just return the response.data portion, because I'm not interested in the rest of it. So this is returning on this function, and this is returning on this function.
So if you didn't do the .then, it would just return the whole promise?
Right, it would return the whole response, and this is just my way of plucking out only the piece I want.
So then wherever you call get info, so like right now on line 10, when you call that, could you, if you didn't do the .then, could you do the .then to get movie info by title on line 10?
On line 10, yeah, I could do that there and then go through the array of all of them and look for their data and like map their results to their data and then return that as a promise.
Okay, that kind of makes more sense. I like the way you did it more, but just that kind of makes more sense.
Yeah, no problem. But anyway, you could see that we could even intrude more into this. We could add an option like, hey, ask more. What if we added like a, are you sure? Whenever they say, no, we don't want you. Like, we don't, would you like to know more? If they say no, we want to ask a confirm screen that says, are you sure? First of all, let's modify our diagram. What modification would I need to make if I want to say, if they say no, we'll move all of these into the correct place. What if we did a confirm screen on here that said, they ask details, it's like, are you sure? And they say yes. Let's see, let's write that all out. So if they say that they want We say, are you sure you don't want the details? If they say yes, then we take them to ask start over. If they don't want it, then we actually take them back to ask details. So how would we draw that on here?
So you're saying when you ask if they want details and they say no, and then you say, are you sure you don't want details?
Yeah, so let's write it out. So we ask, do you want to know more? Let's like just write out the path. And if they say no, we want to now ask, are you sure you don't want more details? And if they say yes, then we take them to ask start over. Versus,
Like, well, go ahead.
oh, yeah, and then if they say no, then we ask, do you want to know more again? So
I feel like if they said no there, I'd just go to movie details.
for sure. And we could decide to do that. Let's change it. Let's say, go straight to movie details. Let's try that out. But how would we update our diagram?
Instead of going from ask details, like ask details right now goes to get movie details and start over. So instead of going to ask start over, you need another circle like kind of in between that.
Yeah, like
So we need
exact opposite of movie details.
So we need another circle here that we're kind of inserting in the middle. That itself can go to ask start over if they keep confirming it. And it's good to label the arrows sometimes as well. So we get rid of this guy. I'm going to get rid of that part. We'll put ask movie details back on there. And so anything else, let's label this one confirm no details.
I mean, you would have an error or an arrow from confirm details to ask movie details.
Sounds good to me. So we now have this updated diagram, and this will kind of tell us what we need to do to make those changes after we've updated the diagram. So we're going to go back to index.js, and we notice that arrows changed for ask detail, and confirm no details is this new one. So we're going to need to modify ask details, and we're going to need to add a new function called confirm no details and put it into the chain. So let's go over to index.js. So first of all, I'm going to come down here. I'm just going to add a new function called confirm no details. And we'll put that on here. Would you like to know more? And then we'll say, are you sure you wouldn't like to know more? Or so that it doesn't interfere with the diagram. There we go. So if they do, then we'll take them straight to start over. Otherwise, we'll call console.log. I knew you were just playing. And then we'll call get movie details. Oh, forgot that end right there. So that handles this part, but now we need to go to ask details and change that. So instead of going to ask start over directly, we go to confirm no details. And that's how we can sort of, as we change things over time and we update our diagram, it very easily shows us where we need to make the changes, what functions we need to make the changes to. And there might be some extra pieces of data that you need to worry about, but we're kind of storing those globally. as we're dealing with this big UI infrastructure here, which can be a little bit tricky since there's so many different branching options. But this technique is sufficient to get your homework done at any rate. Because you can ask like, hey, what is this person? What type are they? And then you could push that information into array. You won't be pushing in movie titles, you'll be pushing in objects that describe the person. So you'll have more, your ask movie section will be more detailed. And instead of doing ask movie details, you'll be outputting an HTML file based off of that info. But the structure of it is very similar. Cool. Hopefully that helps. So that's how you can sort of start with, hey, what is the sequence of things that could happen? Turn it into a diagram, turn it into a series of functions, see how those functions are related and how they call each other.
Thank you. That was super helpful.
Thank you, Eric. That was awesome.
No worries.
Thank you for your time. I know we're quite a bit over.
We're a little bit over at this point, but yes. I'll go ahead and post these two files in office hours if y'all want a copy of it. Nothing particularly special. The API isn't even that complicated, but you should be able to kind of use that as a starter point for it. Alrighty. Any final quick questions I can answer for y'all?
Not for me.
All right.
So,
Without
good
further
weekend.
ado then, I'm going to end the meeting. Y'all have a wonderful weekend. I'll see you on Monday.
Bye, y'all.
See ya.